All right, so the next thing to learn about polynomials, since we are going to be trying to graph these functions with a calculator, is we want to know what is the end behavior of the graphs of polynomials. What do the graphs look like at the extreme ends? Do they shoot up or shoot down? Turns out the polynomials have a property that they're always shooting up or shooting down on the ends. With the one exception is when you have a constant polynomial. So if you have a constant polynomial, then you just get a flat line, right? But all the other cases, you're shooting up or shooting down. And it all depends on what this leading term is here. Okay, the leading term is that's the term when a polynomial is in standard form. The leading term is has the highest power of x that you see. And the reason for that is that this term, this x to the n, is going to grow faster than the other powers of x. So if this is becoming a very large positive number, then this whole thing is going to be large and positive in the long run for large values of x. And if for large values, if this is negative, then the whole thing will be negative in the long run. Okay, so to see what happens, if we were just to focus on this term here, we can see, well, if we need to know what the sign of this an is, the leading coefficient. Is this positive or negative? And then we also need to know if n is odd or even. Okay, because if x is a negative number and n is even, then this is going to be positive. But if x is negative and n is odd, then this is x to the n is negative. Okay, so that's really all we need to do to find the end behavior of a function. And we break it down into these four cases. Okay, if n is even and the leading coefficient is positive, the graph shoots up on both ends. Okay, that makes sense because this is in that case, this is positive and this is positive. X to the n, if n is even, x to the n is always positive. Okay, so we have a positive times a positive. So the graph shoots, the function's positive, so it shoots up on both ends. If n is even and the leading coefficient is negative, then we have a negative times a positive, and the graph shoots down on both ends. Then if n is odd, sometimes this x to the n will be positive, sometimes it will be negative. Okay, so depending on the sign, let's say if we want to know what happens on the right, extreme right, x is positive, right? So if we have this is positive, then this will be and this is positive, the whole thing will be positive. So it shoots up on the right. But on the left, x is negative, and x to the n is going to be negative. And if a sub n is positive, a positive times a negative is negative. So that's why it shoots down on the left. And then, conversely, if n is odd and a sub n is negative, the graph will shoot down on the right and up on the left, because now everything will be reversed. We're changing the sign of this leading coefficient here. All right. So this is what to keep in mind. So in a way, it's kind of simple. You just look at the leading coefficient and it tells you the story. So, for example, in 3a, the leading coefficient is x to the fifth, right? Okay. So this is actually the same thing as 1 times x to the fifth, right? So that's going to be, we can see that n, the degree is odd and the leading coefficient is positive. So we're in this situation. So the graph is going to shoot up on the right and shoot down the left. All right. So it's going to shoot up like this and then shoots down like this. We don't know what's going to exactly how far off before it finally shoots up. We don't know exactly what's going on in between here, okay, or how many times. We know we can see the graph is going to have to cross the x-axis eventually, but we don't know exactly how many times, okay, or where it does, or how many turning points there are. But we know that the end behavior is determined by this. If we look at part B, if we were to multiply this out, this would be negative x cubed plus some other terms, right? And we don't really care what the other terms are. We just need to find what the leading term is. And here, the degree is 3, so it's it's odd, and the leading coefficient is -1, right? We can write this as -1 if we want. Okay, so now we're in the opposite situation right here, right? If it's shooting down on the right and up on the left. And again, we don't know exactly what happens. It's in between. But that's the end behavior. Here in part C, the leading term is -5x to the fourth. So the n is 4, so that's even, and the leading coefficient is negative. So we are in this situation, so the graph is going to be shooting down on both ends. Okay, and we don't know what happens in between. The graph might cross the x-axis, it might not. Okay, but we can see it at some point it has to turn around at least once and then come back down here. Okay, and then for part D, we can see if we were to multiply this out, the leading term would be x to the 6th. Okay, so the degree is even, the leading coefficient is positive, so that's 1, so it shoots up on the right and the left. I should say that these are very incomplete graphs. Okay, like I said, that there really aren't any breaks like this, right? We would have to, but the problem is we're just right now we're just considering the end behavior. Okay, if I were to ask you to finish this, we're going to see that in the case of example B, the graph is actually going to hit at just the x-axis once at -4, and it's going to come like that. Okay, and we'll learn how to find the x-intercepts in the next video. Okay, but that's how the end behavior works. Just look at the leading term.